Hello, and welcome to today's presentation. I really appreciate everybody taking the time to join us. Today, we're going to talk about how we could increase the probability of detecting indications with video borescopes by using some image management tools. But before we start, I'd like to talk about a couple of housekeeping items. So before we begin, just know that you have at the bottom of your screen multiple application engagement tools. You can use these and resize them and move them around, so set up your space how it's most convenient for you. I'd like to also just let everyone know if there's anything you see today that you like or want to learn more about, you can get in touch with us. You can request to book a demo directly from your console if that's what you want to see. So please take the time to do that if that's interesting for you. Remember that the slide area can be maximized to full screen just by clicking on the arrows in the top right corner. And then lastly, if you have any questions during the webinar, you could submit them through the Ask a Question engagement tool at any time throughout the session. We'll probably get to most of the questions at the end of our content. If there's questions we can answer along the way, we'll do that, and you'll see those answers show up in your console. We do capture all questions, so if we were to run out of time and haven't been able to answer all the questions, know that we will follow up, answer those questions, and send them all out to you via the email that you signed up with. And then lastly, if you could do us a favor, just take a few minutes, complete our survey, and that'll help us understand if this was valuable content and or let us know what other content you want to see in the future, and we'll try to make that work. So with that, I'm going to start the session today. Today, you have three people that are going to talk to you. My name is Tom Ward. I'm a product manager for Waygate Technologies. I've been in this business for over 30 years. I currently manage the Mentor Visual IQ video borescope. With me today is Dennis Lavin, my colleague here in Skaneateles, New York. He's been with the business around 20 years and manages a different product line called Everest Mentor Flex. So we've got choices for you. And then we're very happy to have Tom Danvers. He sits over in the United Kingdom, and he has over 20 years of on-engine borescoping knowledge. He's a subject matter expert on a variety of different applications and even has spent a lot of time really figuring out how to solve problems in a borescope engine. And he's going to share some of his thoughts with us as well today. So exciting day, a lot of good content. Just to go over the agenda today, today's session is going to be about what we call probability of detection, POD. And as anybody that's an inspector knows, image quality is a key to being able to see what you need to see to understand if an indication is in fact a defect and you need to do something about it, or just to make a decision and feel confident in that decision. And we at Waygate Technologies have developed some additional image transformation tools that can help you identify these problems even better. So we'll do some live engine inspection today and talk about HDR. You maybe know a little bit about HDR from your cell phones, taking images. We'll talk about a live tool called Dark Boost that can help you with different scenes in an engine, and talk a little bit about distortion correction. We'll have some images in a weld application where we can look at color saturation, and we'll talk about a way to take some of these image transformations and set up a preset so that if you use them all the time, you don't have to take the time during each inspection to set them up. You just hit one button and they are already turned on for you. And then finally, we'll turn it over to Mr. Danvers, who will take you through very exciting assisted defect recognition analytics that we've developed. And we'll talk a bit about that as well as a blade counter analytic that we've developed. So with that, what I'd like you to do now, just before we start, is take a look at the poll question that you see here. Take a look at these areas and let us know, and you can click on more than one. Are any of these items on the screen now things that you struggle with, or you'd like to see software that helps remove them? Let us know, and we'll talk about that in a second. Now, Dennis and I are going to move away to our inspection area, and I will then comment on your questions, and we'll get started, or your answers to my questions, and then we'll get started. So hold on for 1 second. Thanks. Okay, I'm back, and I see that you guys have taken the opportunity to answer a lot of these questions. This is great. Glare and hot spots, not surprisingly, as well as being able to see the area of interest. So a lot of interest in those areas. That's good. We're gonna spend some time showing you some ways that we've tried to solve those problems. Color representation. Dennis will take us through a way to bring out color. He'll go through that a little bit later. So good. I appreciate your feedback there. Good for us to know. So before I start my live session, what I'm going to go over today is three different things. I'm going to talk about what we call adaptive noise reduction, and this is a way to remove noise that you see in images, especially when you don't maybe have enough light and the gain's kicked up. You see a lot of what looks like snow in the image. We've developed a way to reduce that. As well, I talked about it earlier. I'm going to show you quickly how you can create a preset using 2 or 3 or more of these image transformations, and then just refer back to one button to click it on in case you're using that in a particular application all the time. It's really more of an efficiency gain for you. And then I'm going to talk about a still image transition that you can make called high dynamic range. So that's where we'll get started. So for today's examples, I'm showing you a Mentor Visual IQ Analyze system with a 6.1 millimeter by 3 millimeter HD video probe, and I'm using a black forward 3D phase measurement tip. The great thing about that tip, it can be used for general inspection and then on-demand measurement if you find something that needs to be measured. And then lastly, I just like everyone to know, anytime we put software out, we generally do 1 to 2 software updates on our Mentor Visual IQ per year. And at that time, any new features that we offer that we're going to sell, we provide them to you free of charge for 90 days. So that's 3 months. So always make sure you update your software. Your Mentor Visual IQ will tell you that it has a software update if you're connected to Wi-Fi, some type of hotspot. So keep a lookout for that, and then you'll see that you have the ability to use any of these new tools that we talk about. Particularly this time, the assisted defect recognition stuff and the blade counter stuff, as well as a tool called image stitching that goes along with measurement, are available today for 90 days if you haven't updated your system already. All right, let's get started. I'm going to share my screen. Okay, so everybody should be seeing a screen share. I'm inside a combustor section of the engine here. And what I'm talking about with you now is called adaptive noise reduction. And what we do is we actually average up to 128 frames to reduce visible image noise. So when there's no motion, it really works really well, and you see a nice smooth image. And for that reason, we actually, behind the scenes, enable adaptive noise reduction on any still image that you take. So you'll always see that. Let me give you an example of how this works. So in this area, if I just zoom up a bit, you can see all that sort of noisy snow in your image. So if I freeze the image, like I said, we employ it on all frozen images, and that would include the saved image that you have. You can see how that really dramatically changes the image and gets rid of all that noise. Now, if you're doing a live inspection, you can do the same thing by going into our image menu. So I'm going to select the image menu tile. You should see it flash blue. And you'll see here I have all of these, what we call probability of detection tiles. So image management tiles. Some of them will be obvious to you, like brightness, maybe long exposure. You can turn your illumination on and off. In this case, I'll go and I'll select the adaptive noise reduction on, and I'll put it on, as you can see there. And you can see now I have that kind of smooth image. So as I said, we're averaging a bunch of frames. So the system is smart. When you see motion, and I'm showing motion right now, you can see how that noise will tend to come back while the system's recalibrating and averaging the frames. As I stop the motion, it displays those average frames, and you can see that that's a much nicer image for you. So if there's a particular application where you struggle with the noise, maybe if you're using, as an example, a 4 millimeter product, which has less resolution camera. I'm using an HD camera with over 1 million pixels. You have about a 440,000 pixel imager. You may notice a little more of this noise, and this can be a useful tool. It also depends on what tip optic you need to be using. So know that you have adaptive noise reduction. As I said, live image, it comes with every system we sell. For still images. for using live, this is part of our POD packaging, can be quite helpful. Now I'm going to move on. We'll go back to the full image here. And I'm going to go back into this image set that I showed you. These are the live transitions. And so let's say that I want to, again, put adaptive noise reduction on. Maybe I'll go back in and I'll take the brightness up just a couple of clicks. And maybe I want to go in and I'm going to maybe try to draw out a color, a little more color. You can see how that's changing there. And Dennis will talk a bit more about this in a minute. So, and then maybe lastly, just for this demo, I'll hit invert because I want to, maybe I've got something I need to read in there, or I want to see it in a different perspective. So now that I've done that, you'll see that on the bottom of the screen where it says save to preset, I simply select save to preset, and it's saving everything that I've just selected. I click on preset 1, I name it, say, demo 1, we'll say, or emo 1 in this case. So now it's saved that, and you see on the soft keys at the bottom, you'll see that what was supposed to be demo 1 is sitting there, and now next time I come in, that will be there. You can boot the system off, it'll be there, and you can go ahead and select that, and all those image presets will turn on for you. So it's just a good little efficiency gain when you're doing that. So that is A&R and presets. What I'm going to do now quickly is I'm going to change to a different spot in the engine. So please hold. You're going to see the screen go blank for a second. I'm simply switching over my video stream to a different camera system and waiting for it to re-come back. I think you should see it now. Just wait a second for that little control panel to go away. There it goes. Okay, so now what we're going to talk about is called high dynamic range imaging. And you can see here, I have a frozen image of a compressor blade. You can see how that compressor blade's got a hot spot in it. Let's say that that's the area of interest that I'm interested. You could, again, see on the Mentor Visual IQ on the bottom, we have our dynamic soft keys. These are cool because they change no matter what you're doing with the system, whether you're doing file management or measurement or analytics or live or still, they'll change and provide you the tiles for what you most likely will want to use. And just to share, you'll see this little button on the bottom. You can go back. There's 8 of them there. So you can go back and forth and see everything that's in there. In this case, we're talking about probability detection. So for HDR, I can go into this Views menu, the far left soft key, and you can see that I have some options here. And I said I wanted to get rid of that glare hotspot. Well, we got a quick and easy way. We've got the dark version of HDR. I click on that, and you can see how that's cleaned up the hotspot quite a bit, right? I'll show you that again. And so now you could see what might have been hidden behind that glare spot. So then, now we're back to the regular image. If I go in here and maybe I want to see what's over to the left, which is kind of dark, I can hit the bright tile. Now you can see how you can go back in there and it's really well illuminated in there and really hasn't washed out on the right-hand side of the image all that much. And it's because HDR is a technique that we use that combines multiple images and they're captured at different exposure levels into a single image, and that really improves the visibility and the brightness of every of the dark and bright areas in the same viewed scenes. But what's really neat is you have some control here too. If I go back into views and I hit the variable button, I can then, you should see now on your screen a slider bar, and I can take that up or I can take it back and adjust that scene however I want it, depending on what part of the image that I want to look at. That's called high dynamic range, and that is also part of our probability of detection package. So please make use of that. Please ask questions if there's more you want to learn about that. Right now, I'm actually going to now hand off this presentation to my colleague, Dennis Lavin, and he'll take it from here.
Okay, thanks, Tom. So Tom took me through a few image transforms. The last one, HDR, there is a live image transform. I'm going to focus, or excuse me, still image transform. I'm going to focus more on live image transforms on the Everest Metro Flex Video Pro. Before I jump in, if you could do me a favor and just go ahead and answer this first poll question. So if you're a video Borescope user, do you employ image processing techniques to improve your probability of detection. And I've listed a few here. So you have brightness. So that's obviously increasing the brightness of your video borescope, the auto gain and exposure levels. Do you use noise reduction? So what Tom took you through, ANR, a way to reduce image noise in dark scenes. HDR, high dynamic range, which Tom just demonstrated. Is that one that you employ? Color saturation, I'm going to go through that in a moment here and take you through on a weld coupon to show you what that's like. And then gain adjustment. So take a few seconds, go ahead and answer if you use any of those image processing techniques. Okay, so let's go ahead and take a look at the results here. Wow, so image brightness is the clear winner. So not surprising that image brightness would be used definitely in some reflective areas, and potentially we'll take you through dark boost, which may be an improvement in a technique to use instead of brightness, especially in shiny areas. So what I'm going to do here, I'm going to take you through a couple live image transforms first on this PowerPoint slide. Then I'm going to pivot over actually on an asset and do a demonstration with our Everest Mentor Flex. So the first image transform that I have is called color saturation. This is a really popular use case in weld inspections. So what a weld technician will do is they'll evaluate a weld and they're really paying close attention to the heat affected zone of that weld, particularly in high purity piping in the pharmaceutical industry. That color of the heat affected zone is critical, and there's certain standards that they need to adhere to. So they might have a known good sample like a weld coupon to compare to, or a color chart like the American Welding Society will have a color chart that they compare to. And if it doesn't meet that requirement, the weld gets rejected out of fear of, it could lead to increased risk of corrosion if you don't meet that standard. And so what color saturation does is it allows you to manually adjust a live image to bring out colors that are important to a particular application. So what it does essentially makes your job a bit easier, your decision process a bit easier, because you can really see those colors a bit better. So I'm going to show you that on a weld sample here in a moment. The next live image transform that I have is called Dark Boost. The way to think about this, it's a very valuable tool for any application you have that has shiny surfaces. So I'm going to show it in the compressor section of a CFM56 engine, the one that we're on right now. But it's not just for aerospace applications. This might be valuable in pharmaceutical, high purity piping where it's very shiny, or even in a wind turbine gearbox where you have parts that are covered in oil and very reflective. So anytime you have shiny surfaces, what happens, and those of you who use video borescopes, they have very powerful light output these days, especially the Mentor IQ and Mentor Flex. So what you're going to notice is in shiny areas, the foreground is going to really bloom out and get very bright. And then naturally the background is hard to see. It becomes very dark and you can't really inspect back there. So what Dark Boost is, it's a live video processing function that digitally brightens darker areas of the scene without overexposing the foreground or blooming that out. And then it's going to brighten up the darker areas in the background. So it's always assessing the brightness content of a scene and intelligently adjusting the gamma correction levels. Okay, so very helpful tool. Remember this one anytime you're in a shiny surface scene. Okay, so with that, what I'm going to do is, if you give me a moment, I'm going to share my screen and go over to the video borescope on the engine here. Okay, so we'll let the control panel go away there. And what you're seeing now on your screen, I have a 6.1 millimeter Mentor Flex. I have a side view blue tip adapter on, and I have it in a coupon of a high purity pipe showing a weld sample. And you can clearly see the heat affected zone there. You see some coloration there that you'd want to be inspecting as a technician. Some welds might not be this obvious. And so what I can do if I want to bring out some of those colors is I'm just going to tap the image soft key, and then I'm going to hit color saturation. So it brings up this slider bar. Now I can manipulate this with the touchscreen. If I had gloves on, I could use the joystick. I prefer the touchscreen, it's a bit easier. So as I move the slider bar up, you're going to see those colors really begin to pop. And it's really very apparent what colors we're looking at, right? So it just makes the decision process a bit easier, a bit more obvious to see, what is that heat affected zone looking like? So it really brings out the colors there. So that's color saturation. So now if you'll give me a moment, I'm going to remove the probe from the coupon and take it out of my gripper. And I'm going to go over and show you dark boost. I'm going to have to put it into the compressor section of our CFM56 engine. So I'll take off my centering device and my gripper that was used in the high purity pipe and go right into the engine here. Okay, so usually takes a minute to get it right in the port where you want it in our center or gripper. And here we go. Okay, so let me get it locked in with my port coupler here. So what's the first thing you notice is a very shiny blade right in the middle of our scene here. And if you look on the left side, so you obviously have a ding in that blade. And if you look on the right side of your image, what if I wanted to inspect that defect in the background there? It's very dark. Now, my natural instinct is just to hit brightness, right? So I'm going to take the brightness, I'm going to crank that up. Now I can see it, but I totally lose that blade. It totally blooms out. The defect might as well be gone because that's just increasing your gain and exposure levels. So alternatively, what I can try is dark boost. So I'm going to hit image. I'm going to hit the dark boost tile. Now I have a similar slider to color saturation. If I turn this up slowly, what you can see there on the right side is it really brings up the brightness levels without, I can still see the defect on the left side. It's not overexposing that. And then on the right side, I really have some increased probability of detection there on the right side of my screen. So dark boost is really what you need if you have bright foreground and dark background. So if I turn that off for a moment, one other thing I'd like to show you is, especially if you're turning an engine, so I have a turning tool hooked up to this engine right now. It allows me to turn the engine without having to use a wrench. And so you can see I'm using my future drive turning tool, turning the engine. Well, this borescope is smart enough where it's automatically adjusting the brightness level to maximize the optimum image quality. But what if I don't want that brightness to automatically turn down as the blade comes closer to the tip? I can actually use a feature called exposure lock. And what this does is it sets a floor basically for the gain and exposure of the product. So it's going to fix that brightness. And when I turn the engine, I can see behind it better, and it's going to give me a more consistent level of brightness as I watch those blades pass by. So that's exposure lock. Okay, so with that, what I'm going to do is stop sharing. I'm going to send it over to my colleague Tom Danvers over in the UK to talk about assisted defect recognition.
Hello, everybody. Yep, hello. My name is Tom Danvers. I'm over in the UK, and thank you for joining us today, taking time out of your busy days. So yes, I'm going to be bringing you a different element to the POD discussion that you've heard of so far, as opposed to sort of interacting with the image transforms that exist on the borescopes to enhance the live image. There are other tools, and I'm obviously going to be talking to you really about analytics, other means upon which that you as an inspector can now begin to utilize on your borescope in order to improve or increase your ability to detect defects whilst doing live inspections on the engines, whether it's gas turbine engines or perhaps other applications. I'm going to be talking to you really exclusively around gas turbine applications, but analytics, if I just spend a few minutes really talking to you about what they are, before sort of posting another poll question. I really wanted to just as a definition of an analytic, it's a new button that exists now on the Borescope on the global menu. Once you've updated your MVIQ to 3.6 software, well, actually the latest one is 3.61 that went live just last month. You'll see this new button called Analytics, and that takes you into this space where a range of both still and live analytics exist on the Borescope. They are available to everyone that upgrades to 3.6 on a 90-day free trial. Thereafter, it's a paid-for feature, regardless of which sort of Flame handset you're operating. So the still analytics that we have today are assisted defect recognition analytics. So these are sort of artificial intelligence-based machine learning algorithms that enable you, as ADR would suggest, enable you to assist you in the recognition of defects that have appeared on your screen. These are still analytics today. As we move forward and develop and enhance this capability, we'll be working towards making that happen in a live sense. But at the moment, in the near term, we have still analytics, still ADR analytics that are available to you on the Borescope. And then by pressing the live analytics page, you get to see a blade counter, another example of helping you carrying out your tasks such that you can really spend most of your time doing what you're really meant to be doing, which is obviously performing an inspection. So I'm just going to post you a question before talking really more about the analytics on the Borescope first, and take you through this. So really, what I would really like to understand, what is it that you spend most of your time sort of grappling with? What are the greatest challenges that you face today with your in situ visual inspections? Is it really getting to the target, as I would class it, sort of obviously removing your access port, inserting into the engine, and negotiating to where your target component is, whether it's a blade or around a combustion chamber? Is that the greatest challenge? Or are there challenges associated with what I would describe as human factors, those external sort of influences that affect you as an operator, working either at height or in the rain or up at in sort of challenging physical sort of environmental conditions? Are those the kind of challenges that you face that kind of affect your sort of ability to do your work? Perhaps it's not that, and it's time pressures, for instance. Everyone's very busy. I understand, because I've been there myself. Given a certain amount of time, especially if you're working on the line to carry out certain tasks, things happen. You might encounter certain objects, certain features that might change the scope of the inspection, for instance, especially if you start having to measure them and sentence them and interact with your procedures to determine whether they're acceptable or not. This can all affect your time. Or is it the actual procedure itself? Some of the inspections are easy and very quick to do, don't require you to really negotiate the probe very much into the engine and just keep it still and rotate and off you go. And others are very challenging. So yeah, just I'll give you a few more seconds before taking you through seeing what responses you've been able to provide. Very good, thank you. A good blend then is what you're saying. Thank you very much. So yes, all of those things, I suppose, is what I would read into that. But obviously there's one that's kind of sticks above the rest, is basically getting that probe from outside the engine to inside the engine in terms of getting to where you need it to be. So thank you for that. So I'm really kind of taking you through that kind of thought process, because really analytics are designed to really help in some or all of those factors that I've kind of taken you through and we've just mentioned. Yes, as I was saying in my introduction, I'll be talking to you about ADR and also blade counter. Before I share my Borescope and take you through some sort of demonstrations on my Borescope, I won't be sat in an engine. I'm sat in my office in the UK, so I've got some sort of pre-recorded videos and images that I can take you through. But as an introduction, so yes, the application being gas turbine inspections, whether it's aviation sector, the power gen, or perhaps elsewhere in oil and gas, for instance, but rotating gas turbine sort of turbo machinery sort of assets, really start to become or can be using the analytics that we've designed today on the Borescope. These are now available today. So I'm just going to mention a large part of those analytics, the ADR section, and we've partnered with a company called Air Innovation. So they are the world leading sort of provider of assisted defect recognition analytics to the aviation marketplace. And we have been able to successfully operate those analytics and expose them on our operating system for the MVIQ Flame handset. So why would we want to do that? It's providing that ability to really help you and assist you in performing your activity. Make it more repeatable, such that you and your colleagues can have the same technology running in the background, so that you have the ability to not just perform the inspection as you've always been doing, but you can rely on technology to be able to sort of assist you in that ability to detect. I'll take you through some of the workflows associated with categorizing the defect, as well as performing sort of approval and rejection sort of steps on the Borescope. And those today, yes, they are based on still images. So this doesn't yet work on the live state. That's coming up in the near future, such that we aim to be able to perform this activity in the live sense. But so far, we've developed a very robust way upon which we can do this in a still space, whether it's in freeze frame or in recalled images. And then I'll take you through briefly. These are all very large soft topics, but I'm just really touching at a high level the other analytic that we have today on the Borescope, this being a live analytic, being blade counter. So yes, that's the snapshot that you see on this slide is actually a blade with a text box that says blade 1, and then you see 3 lines. Those lines either can appear or can be made to go away whilst you're doing your inspection. And that kind of setup is required by the operator to assign those lines onto the image, such that you're telling the analytic, this is the edge of a blade passing by this region of interest. It's triggering at this point in the center where you see the yellow line. There's a little central sort of cursor point that we call the trigger point. And that is the point upon which that edge of the aerofoil is triggered, and the count in the text box moves, in this case, from blade 1 to blade 2, for instance. So what has this got to do with probability of detection? It really lets you sort of not focus on the attention, the counting, whether you're counting with a clicker or just counting in your head or out loud. It's very easy to get distracted and miscount. It's easy to mislabel. It's time-consuming to mislabel. So really, there's a whole host of sort of tasks associated with counting and labeling on the device, which are really now removed by using the blade counter, so that you can really focus on what you're really there to do, which is obviously inspecting that part and making sure it's safe for continued operation. So yeah. I'm going to now just take a moment, share my screen from my Borescope, and take you through some live demonstrations. So, okay, hopefully that's coming through well. So yeah, just showing you, hopefully that's come through. Oh no, my mistake, button problems, window, there we go. There we go. Excellent. Actually, I just wanted to quickly show you, if you hadn't already been aware, this is my MVIQ, and it's now operating on the latest network, latest update, which is 3.61. And I'm just highlighting you this new button. There's another new button there that you'll see might have noticed that says store, but I won't be talking through that. But this analytics space, so if you enter analytics, accept, and then you enter into this space associated with still analytics and live analytics. So there we have the defect recognition analytics from Air Innovations, and we also have developed one in-house within Waygate as well, called LM2500 Assist. So that's just quickly showing you, where they can be found once you've upgraded to 3.6 and you now have access to operate those analytics at least as a 90-day trial. Okay, so let's just go in. Suddenly it's very slow. Okay. So here's a video. I'll just minimize my buttons, which I like doing. Hopefully this is coming through well. This is a video, and it might be a bit jerky on the screen because we're obviously transmitting through the internet. But this is a short clip of me actually examining an engine a few months ago where I was performing an inspection, and in this case encountered some nicks on the edge of an aerofoil. And I had in the background the defect recognition analytic from Air Innovations activated. And you can see briefly when I tap the screen, it takes about sort of 200 milliseconds or so for the analytic to activate and analyze the image and return whether or not a defect has been detected or not. This happens very quickly, and then you're invited on the Borescope to interact with that analytic in terms of accepting, rejecting, and also changing the classification of that defect. I chose not to do that on that video. What I will do, just to spend a little bit more time with my Borescope, it's just taking a while to load. Okay. Right. So that was one of the still images that I had captured. Just go to full image, full screen. So here we, having tapped the screen and entered the freeze frame state, and then within a fraction of a second, the analytic basically returns either some bounding boxes, we call these bounding boxes, or none if it doesn't return anything. In this case, the analytic from Air Innovations does not classify the indication. The return is basically classification is really reliant on the trained operator to basically determine that defect classification. The other analytic that we have from Waygate Technologies based on LM2500, that does have categorization capability. Nonetheless, here we go. We kind of have the ability to then review the indication. So it's picked up some deposits and some features in the background on that stator vane upon which you can reject those. And here's an instance where you can see quite clearly there is a very minor sort of nick on the edge of this aerofoil. And you can, by accepting and rejecting, what does that mean? That really kind of enables you to basically not have to accept everything that the algorithm is returning for obvious reasons. It's not perfect. In this case, it's about 85% sort of accurate for this kind of stage of the engine. And you can also, by pressing edit, you can add a classification. Well, I've changed that to be nicked, which I rejected, so I can change that back. Highlight my accepted one and assign that to be nicked. By saving that image, you don't lose anything. You don't lose the fact that you rejected the bounding box in the background, for instance. That basically is always there. As you can see on the blue text on the top right-hand box, the info panel will always say 2 indications when you load that image back up. So I'll save that now. I'll save a new. So when I load up that image, just to sort of demonstrate, come on. So that was the image that I'm just loading up, I've just saved. You still see the fact that it says 2 indications were detected, but only 1 is presented on the screen because in this case, 1 in the background was rejected. So just demonstrating to you that information is not lost, it's just if it was rejected, it would just not be made visible. So that's all data that is always retained within the image, within the JPEG image that gets saved once an analytic has performed its operation. So that's just briefly the workflow associated with interacting with a defect recognition analytic today. So this is, I was just taking you through Air, Light, Rotate. Just wanted to spend a few minutes showing you the other analytic that's offered by Air Innovation. It's kind of packaged as one part number. So it enables you to carry out basically a front to rear inspection of your gas turbine, moving through the compressor stages into the combustion chamber, and then obviously through the subsequent turbine stages. So the air light combustor is the analytic that really is trained on thermal barrier coated components. So that could be just the combustion chamber alone, or it could include components within the high pressure turbine, for instance. So here we have examples of images from the HP turbine. And as you can see, by tapping the screen, entering freeze frame, it's delivered this bounding box associated with the erosion that you see, associated with the leading edge of that turbine blade. And you can, by swiping the screen, there's a sample image that doesn't have a bounding box. So what I can do on my borescope, turn on the analytic, turn on my combustor analytic. Just takes a few seconds for that to fire up. And since this is a saved image, it works on saved as well as freeze frame images. So now you can see the icon in the top right hand side that basically tells the operator in the status bar at the top of the screen. There's a little sort of circle with a few plots on a curve. That's our analytic icon that we now have. By pressing the Analyze soft key, you can see an instance here where it's detected, in this case, a crack associated, certainly a linear indication, I suppose some people would call it, as opposed to sentence it necessarily as a crack. But and then you can either accept, reject, and then edit, and then save. So it's very easy to be able to sort of label and carry out that activity very quickly once you tap the screen. So as you're going through your inspection, it's very easy to tap, 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 and just check, check, and check as you're going through. I'll just show some other images from the combustor. So some more defects here, and let me just, there we go, press Analyze. Very quick TBC loss. So that's a quick run through of analytics, the defect recognition analytics that we have. These are public analytics. It is also possible to host private analytics on the Borescope that your employer might be interested in carrying out certain activities that also require or would benefit from machine learning or artificial intelligence-based analytics. And that is now also possible to be exposed onto the Borescope in a private space, such that it will only be present on your handsets associated with a very restricted and controlled distribution. So there's a mixture of public and private analytics that do exist today. Okay, that's all I wanted to talk to you about quickly about defect recognition analytics. Let me go back and just spend the next few minutes talking you through the live analytics. Today there is only one, and that is the blade counter. And yes, I'm just going to show you, because you'll appreciate I'm not on an engine, so these are recalled videos. So giving you a range of different views in this stage, in this particular case, quite a sort of an acute angle that you'll be familiar with, most of you, associated with the inspection of, in this case, a HB compressor stage. It's very difficult to sort of control the speed and position of the rotor if you're performing sort of manual sort of turning as opposed to using an electronic turning tool. So here's an example where you'll perhaps appreciate it's quite difficult to go slow and smooth. And this is an example upon which you can see how well the blade counter is responding to this jerky movement of blades as you pass between the various blades. And once the idea is that once I haven't really taken you through the setup and the verification stages of blade counter, but you then have the ability to enter your number of blades that exist within this stage. You'll have that in your AMM or your inspection task. And so that when you get to blade 52, it returns back to 1, for instance, and you can have 100% confidence that you've then captured and inspected the full set of blades. Let me go back. Much smoother rotation here of the LP turbine. So there'll be a person sat in the fan inlet spinning the fan blades whilst the inspectors position the borescope at the back end of the LP turbine to inspect, in this case, the shrouds or the tips of turbine blades here. Yes, so the rotor can move forwards and backwards. The blade counter will count up and down. If you chose to stop and you found a defect and you want to call that blade number 1, you can do that. You can go into the settings and change, in this case, blade 25 back to blade 1, for instance, if you wanted to do that without having to set it all up again. And if you're rotating it and you decide to perhaps change the direction or the whether it's counting up or counting down, you can change that in the settings as well. So there's a range of settings within the handset to enable you to change that. So all about really moving that ability, that burden that you have as an inspector to count blades so that you can really focus on the task at hand, which is the visual inspection itself. Kind of just showing you another quick video clip associated with using blade counter. So here's an example that we'll be touching on in another webinar associated with blade tip clearance. So I won't be talking about that specifically here, but here's an example where using blade counter whilst undertaking, in this case, a blade tip clearance survey is very powerful. So it's very efficient upon you to carry out this task. Not just the measurement task, but the labeling task. So you can move from blade to blade to blade, carry out, in this case, a BTC assessment of that particular rotor, and have everything all labeled up for you. So it's a very time efficient process, and you can really, again, keep coming back to obviously your POD, so that you can really focus on the real skilled sort of profession that you have being as an inspector itself. Okay. So yes, going back to the slide. So that's my quick overview of the technology that we're now exposing on the Borescope as a result of updating to 3.6. So just as a reminder, connect it to the network, upgrade your software over the air or via USB. You can download if you have got a handset that doesn't have signal to Wi-Fi, you can download this from the Inspection Works portal and update the system using your USB. Final question, really, from me. You've heard me talk about AI, artificial intelligence, in order to carry out activities associated with defect recognition and blade counting. I'm kind of keen to kind of throw it open to you, really, and ask what other tasks that you would like it to help perform in order to make your job either more efficient, easier, quicker, more repeatable. So yeah, I'll go through the answers while hopefully you can kind of enter your answer. So yes, this is something perhaps that we just continue enhancing the ADR. It works for certain engine types and not others. Maybe wanting to focus and expand that range of applicability to other engine types. Perhaps focus on its ability to perform its task even more accurately, even more precisely. So yeah, that's something that we can focus on. You've heard me mention it before. It's something that we're working on, making it work on live video inspections. How important is that to you? But also, it's not just about detection and categorization. You'll appreciate perhaps we need to move towards measurement of the defects and more associated with the sentencing. And you mentioned it in the previous poll question. In terms of getting that probe to the target, perhaps we can use artificial intelligence to sort of help drive that probe from outside the engine, or perhaps from a given point in the engine to another point in the engine, from A to B. How important is that, perhaps, for you? And yeah, I kind of threw that one in at the end. This one at the end associated with the data plate. Pretty much, I can't think of any engine that doesn't have a data plate, and it's normal to record the information on that data plate when you're including it into a borescope inspection. So perhaps the feature recognition capability, having a probe look at a data plate, would that be something that you would be interested in? And if you can think of anything else that you would like it to be, then please post that in the comments as well. So thank you for that. Good mix again. Yes, so thank you. Clearly the one in the middle where the majority is making it work on live video. So thank you. This is something that we are making happen later in the near future. Not too long now, hopefully, months as opposed to years. So yes, thank you very much for that. But yes, nonetheless, a good mix, a bit of everything is what I'm reading into here. So thank you for that. Okay, I'm just going to hand it back over to Tom Ward now. That's everything from me associated with analytics. Take you back to Tom. Thank you.
Hi, thanks, Tom Danvers. I appreciate that. And so now, everybody, thanks for hanging in there with us. Hopefully there are some questions. I'm going to go and start to answer some of those or hand them off to my colleagues. One question that we have, are the HDR different views? So this is the high dynamic range stuff I showed. Are they available on a 3D image? Clark Bendel, if you're on, could you spend a second or two on this question for us?
Sure, Tom. Yes, in short, you can view the HDR images on top of the 3D point cloud view if you're using one of our real 3D measurement technologies. I should also note that we have a measurement-focused webinar coming up 1 week from today at the same time. You should have a resources section or pane in the console that you're viewing, and if you'd like to register for that webinar, you can do so right in a link in that section. So we'll be talking about our different real 3D measurement technologies, and we can demonstrate at that point how you can apply those HDR views to the 3D point cloud that's generated.
Thank you, Clark. And yeah, another question, I think this is the same kind of comment. How do we measure the depth of defects? So Clark, hopefully you could spend a little time on that next week, but we definitely, depending on your application, can measure the depth of defects. It just sort of depends on what you're looking at, how deep is the defect you'd like to measure, and please join us next week and we can get into explaining a bit of that for you. Another question that was asked, how can I reduce glare in my image? So I'm assuming that was maybe earlier on, and hopefully we've tried to help answer that. Of course, you can try to move the camera to a slightly different angle to reduce the glare back from the camera light. You can mess around with brightness, but of course you can play with dark boost that we showed you. And so dark boost is a good way that Dennis showed of being able to manage brightness. Is there a way to brighten darker areas? Another question in the live image. So that's where if you have a still image, yes, you can use HDR to do that, and it works really well. That's where I showed you in the views menu on Mentor Visual IQ. So hopefully if you have our product, you can play around with that and make good use of it. If you don't have our product, get a hold of us. We'd love to give you a demo and show you those features live on whatever inspection assets you're looking at. Okay, I have another question. This is a good one. We use Borescope for inspecting pipe structure, lighting column, etc. in outdoor environments. And it's really difficult to see the screen for taking best images to detect corrosion. So you're looking at corrosion. Any tips? Yeah, that's a tough one. So Mentor Visual IQ, I'm not sure if you're using that, has a really bright 1400 nit illumination LCD panel. So that works really well to be able to better see in situations where you have sunlight. Of course, if you have sunlight directly on the screen, that can always be a problem. I would guess that you've tried sort of shielding it with some type of umbrella or some type of area. If you'd like to get a hold of us, please reach out and do so reaching out to the sales guy in your territory or through this webinar chat. We could set some time up if I'm not fully understanding your question and talk through that. So we could do that for you. Let's see here. Would this work for T-fairing inspections on the GE7FA? So I don't know if you're talking about the analytics that Tom was talking about. Maybe please chat in specifically what you're asking for there on that one. If you're talking about the image transformation stuff, yeah, it should definitely work for T-fairing inspections. We could have an expert in that area. We have a number of them in our business. Reach out to you and talk through that. Let's see. How do we save files on the D drive? Was having trouble the other day. So when you're trying to save files, at least on the Mentor Visual IQ, you would go into File Manager and you can choose where to save your files. So you can save them on the internal drive, or you could save them on a USB drive. If it's USB, you got to make sure that you have a thumb drive plugged in. If you're still having issues, that's pretty simple to do. So I'm assuming you may be having an issue there perhaps. Please call into our technical support desk. Dan and Jeff are here with me and Dennis in Skaneateles, New York. They will get you figured out pretty quickly. If you got a problem with your system, we'll get that corrected for you. Let's see. Yes, the AI to number the T-fangs. Oh, so counting the T-fangs. So live analytic to count the T-fangs. Please reach out to us and let's have a sidebar conversation offline with you, and we will talk about how we can either get that on our deck or whether or not we can do that today. Tom Danvers, I don't know if you want to take a second on this one.
So just a little bit more detail about blade counter. It doesn't understand what it's looking at. It doesn't recognize blades, but it does recognize contrast. So it's all about, so typically there is contrast between, the leading edge of an aerofoil and the background of the blade, for instance. So provided, because I'm not familiar with the component that you mentioned, but provided there is kind of repeatable contrast that's as you're rotating part, and it doesn't have to be a blade, it could be the root of a blade, it could be the tip or the shroud of the blade, it doesn't have to be the aerofoil, for instance, but provided there are edges or split lines between the blades that provide that contrast, then it's a very good question, and yes, I've proven that blade counter is appropriate and will work in those instances. But yes, reach out with some example images and we can kind of talk through it a little bit more afterwards. That'd be fine.
Yeah, thank you, Tom. And yeah, please get in touch with us. We'd love to explore that further as we sort of begin our journey on increasing the capabilities of our analytics. Another question regarding Inspection Manager 3. So for everybody on here, if you don't know, we have a PC or a desktop application that allows you to store images and various meaningfully remeasure those images. So as long as you've captured these images with inspection, with measurement data, you can open them back up on Inspection Manager, you can remeasure them. The question is Inspection Manager 3 the latest version? Yes. Inspection Manager 3 is the latest version. It is up to date for our current software revision on Mentor Visual IQ, which is 3.6. And on the, Dennis, what's the 1.5 for the Everest Mentor Flex? So those are compatible, and that is where we are today. We will update each of those Inspection Manager to work with upcoming software, usually shortly after we release those software on the video Borescopes. But that's a good question. Another question is, I want to talk about the fact that we will be providing the content here. Any questions, you'll get them back in an email, so you'll be able to see the list of questions that we have. What else do we have? Past years using the MDI, so menu-directed inspection on the Mentor, it has been fast and smooth. Lately, I've been seeing it moving slower and even freezing. My Mentor Flame is updated to latest software. Is there something that can be done to make that? So, yeah, it's a great question. If you're menu-directed inspection, we've improved that over the years and made it more capable. By the way, we're planning on doing even more there, so stay tuned for that. But if you're having some issues there, I wouldn't be able to sort of generically answer that right now. Again, please reach out to our technical support team. They're great and responsive at working with you to sort of troubleshoot and figure out what's going on there. So that's Eric. Please reach out to our technical support team. I appreciate that. That is all the questions that I see currently. Team on the call, anybody see another question they'd like to answer or hand off to somebody? Okay, well, we're a couple minutes past the hour. Again, I would like to thank everybody. Let you know that on your deck, on your console, you should see the ability to click in a number of different links to get more information. Also go to our website. You can reach out to us. There's tons of information out there. And if you go to YouTube, as an example, there's videos on all the stuff that we've done there. So we can help you out there. One last question just popped in from Fabio. I would like to know if AI resource can be trained to recognize damages for other turbines. Yeah, that is a great question. Absolutely. So we have two still image assisted defect recognition analytics that Mr. Danvers talked about. We have one that's a third-party air app that's loaded on Mentor Visual IQ, and then an LM2500. So those have been trained, especially the air, for a number of different engines. So please reach out and get the air info sheet. It's a very detailed sheet that gives you information there to see if what you're looking for is there. But to answer your question specifically, yes, if we have the images, if you want to provide those images to us, we can start training those images for whatever turbine that you're trying to better learn, have the analytic learn. So this would be one you'd have to reach out to us again, and we'd love to hear from you. We can set up some time to talk through what you'd like to, what turbine you'd like to train better. Okay. Again, reach out for a demo if you'd like to learn more. For the folks that might be having a little trouble, reach out to our tech support team. They're great. Take a look at all the helpful links that we have that are on your deck there, and we'll be sending out a copy of this, so you should get an email where you can review this presentation that we've showed today, and you'll be able to get to those questions and those helpful links, and then of course visit our website. There's a lot of good information there. I thank everybody, including the presenters and helpers today on this call, and then lastly the customers that have taken their time to share some time with us. Thank you. I hope everybody has a great morning, night, evening, wherever you are in this world. So long for now.